Hello, Math 2. Today we're going to get into talking about different concepts within triangles. All right, it's a very important concept because it leads to other concepts down the road. So please make sure you try to master this concept. First, we can classify triangles two ways, right? We can classify by angles, and then we can classify by the sides. And a triangle with all three angles congruent, right? That is known as an equiangular triangle. Okay, so if all three angles are congruent, it's equiangular. If all of the angles are less than 90 degrees, right? So if I look at this angle is less than 90, less than 90, less than 90, right? That is an acute triangle. If a triangle has one right angle or one 90-degree angle, it's a right triangle. And if it has one angle that's more than 90 degrees, it's an obtuse triangle. So anytime you're asked to classify by the angles, these are the names you would use. You can also, right, classify by the sides. If all three sides, right, of a triangle are congruent, we say it's equilateral. If two sides are congruent, we say it's isosceles. And then if no sides are congruent, it's scalene. So the first theorem we're going to talk about is the interior angle sum of a triangle. All right, there's many ways to prove this. We did it a couple of times in class, but if you were to take these three angles and add them together, angle A, angle B, and angle C, they would add up to 180 degrees. So right away, when I look at this first example, if I know two angles, right, I can find the third one of two ways. A lot of students like to take the two angles that are given, they like to add them up. So this would give us 100, and then they would say if all three angles add up to 180, angle 1 would be 180 minus 100, which is 80. Now, what I like to do is just take 180 and subtract the angles I know. So subtract the 35, subtract the 65, and you would get 80 degrees. Okay. So now, that was an easy problem. These problems can step up and get a little chaotic, but it's just using linear pairs, vertical angles, and interior angle sum of a triangle. So right now, when I look at this next example, I see that there's three triangles in this diagram. I have the yellow triangle, right? I have the blue triangle, and then the big green triangle. So it's three different triangles within this. Now, to me, the yellow triangle makes it easy for me to find x. I'm just going to do 180 minus that 39 minus that 65. And when I do that, I get 76 degrees. Now there's a bunch of different ways to go from here, right? One, if I look, and I'm actually going to just get rid of that. If I look, what do x and y have to add up to? Aren't they a linear pair, right? Don't these two angles make a straight angle? So to find y, if x is 76 plus y equals 180, all I'm going to do is 180 minus 76, which is going to tell me y is 104 degrees. And now I can use this triangle on the right side to find z. Z would be 180 minus 21 minus 104, which would give you 55 degrees, right? Now, some people will also take these two angles, add them together, and use this big triangle to find z. Okay, so there's many different approaches to that problem. Next example, if we're looking to find the value of x here. Okay, think, what do we know about all three angles in a triangle? All three of these angles have to add up to 180. That's my exact setup. is just x plus that 2x plus the 2x plus 15 all has to add up to 180. So this would give me 2 plus 2 is 4 plus 1 is 5x plus 15 equals 180. Subtract that 15, 5x is equal to 165. And when I divide by by 5, x is equal to, what would that be, 33? And we are done. Okay, so the next theorem is the exterior angle theorem. Now when we look at it, angle 1 is an exterior angle. If we take any side of a triangle and we extend it, right? What's created by this side of the triangle and the extension is this exterior angle. Now, right now, angle 3 and angle 2, if 1 is my exterior angle, 3 and 2 are known as the two remote interior angles. And we say the exterior angle is equal to the sum of the two remote interior. Okay, now when you're doing these type of problems, there are many different ways you can do them. All right, so I'm going to show the couple different ways, and then you can determine what method is best for you. But you still need to know the theorem for certain problems. For instance, some people will add these together to get 30 plus 40 is 70. Then they'll do 180 minus that 70 to get 110. And that 110 would give you this angle. And now, what do these two angles have to add up to? 180. So people would do 180 minus 110, which tells you it's 70. But if you know the theorem, you'll see angle 1 is the exterior angle. 30 and the 40 are the two interior angles. So technically, you could just take 40 and 30 and add them together to get 70. So that's two approaches to the same problem. Now, in the next example, 113 is your exterior angle, 70 is an interior angle, and angle 2 is what we're looking for, and that's a remote interior angle. Well, if you think about it, angle 2 plus that 70-degree angles, if I add these together, they should add up to that exterior angle. So now, when I subtract that 70, angle 2, 113 minus 70 would give you 43 degrees. In this example, right, here's my exterior angle, here's my two remote interiors. All I'm going to do is set my equation up. The two remote interior angles I'm going to add together. So 6x minus 2 plus 10x minus 4. Those will add up to, these two blue angles will add up to that yellow angle, 106. So when I combine like terms, 16x minus 6 equals 106. Now I can solve for x. Add 6 to both sides. 16x equals 112. Divide by 16. And you get x is equal to 7. So now, in isosceles triangle theorem, right? If you know two sides of a triangle are congruent, we can automatically say those two angles are congruent. Okay? So what we say is if sides congruent, then base angles congruent. So in this case, if these sides are congruent, these angles are congruent, so x is 44. So when I look at an example like this, it's a little different because if these sides are congruent, what you have to understand is if this is my base, right, where the yellow meets the blue, that angle is equal to this angle. But here's the thing. If this angle is x, that angle is x, what do all three of those angles have to add up to? 180. So 2x equals, subtract the 72 and you get 108. When you divide by 2, you get x equals 54. So each of these angles are 54 degrees. Now, what other people will do is, this is called the vertex angle. They will do 180 minus the vertex angle, which will give you 108. But if these angles are congruent, they'll just divide that by 2 to get each of those angles are 54 degrees. Again, two different ways to approach that type of problem. So try this next example and then come back and check your answer. So here, I'm going to use this triangle to find x, right? What do all three angles have to add up to? 180. So x equals 180 minus 80 minus 30, which would give you 70 degrees. Now, if this is 70, you know x and y have to add up to 180. So 180 minus 70 is 110. And now I can use this triangle to find z. So y we said is 110. And now z is 180 minus 110 minus 40, which would give you 30. Now, problems like the following one. When I look at this, my goal is to get to this angle. How I get there? Not only am I using the triangles, but I'm going to use vertical angles and linear pairs. So I will fill in everything I can just from the diagram if I cannot get to that angle. So to find that angle, find this red angle here. This is a linear pair. So 180 minus 124 would give you 56 degrees. So this angle is 56 degrees. These are vertical angles, so they're congruent. So this would be 30. If this is 60, this is 30. This angle is 180 minus 60 minus 30, which is 90, which makes these vertical. So that's 90. And now, this angle here, I'm basically using this triangle to find that angle measure. So 180 minus 90 minus 56, which will give you 34 degrees. And now what do these two angles have to add up to? That question mark would be equal to 180 minus 34, which gives you 146 degrees. Okay, so it's taking it piece by piece. Try this next one on your own and then come back and look at your answer. So right here, these two angles are a linear pair. So to find that angle, 180 minus 86 would be 94 degrees. Now, vertical angles here is going to give me 90 minus 68, which is 20, or sorry, excuse me. These are vertical angles, so they're congruent. So that's 68 degrees. Now I'm going to use this yellow triangle to find this angle here. And that's going to be 180 minus 68 minus 52. 180 minus 68 minus 52 would give you 60 degrees. But what does this box tell us? That box tells us these two angles will add up to 90. So this angle would be 90 minus 60, which is 30. And now I can find this angle here by using this triangle. So 180, that question mark is equal to 180 minus 94 minus 30. All right, and 180 minus 94 minus 30 would give you 56 degrees. Okay, go ahead, try the assignment, and if you have any questions, let me know.